Thanks very much.
High expectations, huh? No
Yeah, no problem. No pressure.
Hello. Hi.
Hello. Welcome.
Thanks.
So the intention is to provide an insight into what ARM and our partners and ecosystem are doing to change the industry in the server space. So ARM's historically had strong leadership in power consumption or low power consumption in the mobile space, and we're looking at taking that to the next step into the data center. So I'm going to talk about three items: impact of the mobile industry on computing and how it's redefined expectations, the ARM partnership and how it drives the innovation behind the opportunities, and new revolution going into the server and networking space in the data center. So, despite our relative success, there's a lot more that we want to accomplish moving forward. Energy efficient systems are now starting to become relatively important. It's no longer just about power, as in the strength of a machine, how much gigahertz you've got, how much RAM, etc. There is now also considerations in the restrictions upon data centers. Normally data centers have got lots of space, so putting a rack in is not an issue. The issue is power and cooling. So we've just begun to really bring internet-enabled computing to developing countries. Mobile revolution has started to take off globally now. Smartphones are everywhere. It's not just restricted to cash-rich countries. It's making an impact in BRIC nations, so Brazil, India, China, and Russia, yeah, of course. So it's starting to get everywhere, and data is being generated at a rapid rate of knots. So you're getting cars generating internet traffic, you're getting gardening sensors to monitor your pH levels of your soil, etc., generating internet traffic, mobile phones with the related web services. It's everywhere now. So, working in partnership, we're aiming to transform how the network and server-related components work within the data center. It's not just a simple drop and replace. Things need to be looked at. There's a workload requirement, much the same as there is already on existing architectures. But there are ways where we can leverage our strengths to better serve the marketplace. So, how the ARM partnership works. ARM is an IP company. We don't make anything. We come up with designs. We then license those designs to our partners. So we've got partners who create the CPUs on the left-hand side. As you can see there, there's almost 300 partners that create a CPU of one form or another. We've also got from there our OEM partners who actually build the systems that can then enter the market. And then we've got software partners, operating system vendors like SUSE, Red Hat, et cetera, et cetera. So they build the foundation components before it can hit the data center. But just having an operating system on a piece of hardware isn't enough. There's a much wider scope that requires working. So we then work with other third parties to enhance the operating system layer. We work with other parties that work on key software projects that are then used within commercial products. So we've got Linaro, a non-profit engineering arm that works on a lot of the low-level aspects, fine-tuning, improving performance, and feeding that back upstream so everyone can then benefit. We've also got projects like Zen Project working on the Zen hypervisor to ensure that it works just as well on the ARM architecture as it does on other architectures. And then you've got projects like OpenStack that is used within commercial products in key areas like hyperscale and cloud computing. So working with our partners, we can create a solid base to then get used by people like Open Compute Project and customers elsewhere. So all of that provides an opportunity for innovation, an opportunity to lower your total cost, and gives you a much wider range of choice. So you can choose from one silicon vendor or another. So you could have Cavium and AMD if you wish. Or you could have many more different CPUs within your data center rather than your almost monopolistic options that are in place now. So data center workload is always changing depending on what customers are doing. So it's an evolution. So at the minute, it's a monolithic workload. You just get on and do it. It's slowly going to start not fragmenting, but almost containerizing itself. You will have a dedicated workload for a specific use case. And that will slowly refine itself down and it'll become much more fine-grained, fine-tuned. So over time, be able to focus on the throughput, ensure that the workload is as highly optimized as possible to better meet your needs. So looking at web-scale workloads as an early entrant for ARM in the server space, most workloads are actually I/O bound. There's not that many that are CPU bound. So the fact that you can get 4 gigahertz, 8 CPU, 4 gigahertz each now, it's actually going to be pretty underused. It's going to be your SAN backend that's going to get the most use. Not for everything, but for large majority of tasks. So as you can see there, cold storage, things like Facebook, Baidu, Weibo, Twitter, a lot of those web services where you can upload photographs. 9 times out of 10, for the first month of that photograph being uploaded, it will be accessed maybe twice a day, if you're lucky, 10 times a day. After 1 month, the usage or the access to those images plummets. it may get used once a month, maybe once every 6 months. So having a server that's beefy, all-encompassing, can do whatever you want to serve an image once every 6 months isn't the greatest of use of your hardware, of your data center. You're going to be burning a lot of money for nothing. You could use virtualization for that, but you're still going to be burning a lot of power. So cold storage is a prime example, and actually it's one of the first use cases of the ARM server within the enterprise now is in the cold storage space, running at 1.5 gigahertz with good I/O backend, because that's what's needed. And there are certain cases where CPU is needed, big data being probably one of the bigger ones. But it's not, there's a workload out there for us to fit, not necessarily that workload to fit us. We have our advantages and we can leverage those advantages to the max. So our goal is, the existing ARM ecosystem is very fragmented. The ARM v7 architecture has lots of little oddities. You could get almost the same hardware from one vendor and compare it to the next vendor, it's going to be very different. So for the enterprise, for customers, for OS vendors, etc., it's very hard to support that. So our intention is, with ARM v8, the new 64-bit architecture, is to standardize it. So it's much easier to maintain upstream, it's much easier for our partners to maintain and support, and it's much easier for customers to understand and to leverage to the max. So there is a base server architecture specification that has been released that lays out all those pieces for our partners so that they can work to a common goal. And rather than differentiating on small, insignificant pieces, they can spend more time creating a good product and differentiating where it matters. So I've partially touched on why standardization is important. It's key to ensure that for efficiency, both in deployment, usage, power consumption, that there's a common way to work. People know how things are used, they understand it, they can carry their skills over from one architecture and easily deploy it on another architecture. They don't have to start from scratch, learning it, working out its oddities, etc.
How are you going to do that without open sourcing the drivers?
So how are we going to do the standardization without open sourcing the drivers? Well, all the base components are going upstream. So so we're going to be using a standardized boot method. UEFI is the preferred method for firmware for booting. It's upstream already. Tiana Core 2 includes everything that's needed. We are working directly upstream. There's none of this. Well, we'll work behind closed doors and then do a code drop. It is working upstream. We go to a lot of the UEFI plug fests. We are very active there, and we are also part of the UEFI committee to help shape how things go. So it's much easier for our partners to standardize in UEFI. It'll work across architecture A, architecture B. Doesn't make any difference. They just need to know UEFI and off they go. So that, I mean, we are ensuring that we do as much as possible in the open upstream. So standardizing makes it much easier to innovate. You don't have to take into account oddities. You know where you stand, you can then get on and make sure that your software is highly optimized, it's the fastest to do big data workloads, it's the best to do whatever you wish, rather than going, well, I've got this great idea, work on that. Oh, but I need to take into account if I'm using platform A, I need to do it one way. Platform B, I can't do it that way, I have to do it slightly differently, etc. And it just starts to become monolithic. And then customers don't necessarily understand, well, I bought this platform, got your software, it's supposed to be good for big data, but it doesn't work. Yeah, for that platform I've not tested it on because, well, I haven't got one. If it's a standard base, you know exactly where you are, and it's much easier to improve.
Are you going to have certification on it? Or are you going to keep vendors in check?
You
should repeat the question.
So how are we going to keep vendors in check, and is there going to be a certification process? Part of the way we work is we license our IP. So when we license our IP to partners, there are stipulations over what you can, can't do, etc. I won't go into details because, to be honest, I don't get involved in that in the licensing aspect. But I do get involved in discussions, both from an engineering level and further up on how things are going. And we occasionally get instances where partners think of a great idea and they go down to innovate, but actually they're diverging and then fragmenting. So we have regular discussions with all our partners and ensure that we just pull them back into the common goal. And there's an element of social pressure there. And Linaro is a key partner in helping to make sure that things remain standardized and to minimize the fragmentation. So as I've mentioned, ARM v8's the evolution of the ARM architecture. It's the next step. It's the first 64-bit variant of our architecture. And there's backwards compatibility through time. So ARM v5 introduced Giselle for optimized Java workloads. Floating point. ARM v6 introduced SIMD for mathematical heavy transactions. Trust Zone, a trusted execution environment, enabling much more secure transactions, so you can do mobile payment securely, knowing that there's no leakage there. Introduced Thumb2. With ARM v7, it had introduced an advanced SIMD and improved on the floating point. And then with ARM v8 there on the right, there's two models. You can have AArch64, which is 64-bit, or AArch32, which remains 32-bit. You can have a 64-bit kernel running 32-bit user space, just like you can now on other architectures. And there's improvements to all the core components there as well. And it introduces an optional crypto, hardware crypto ability. Crypto is not a mandatory part of the architecture because some partners don't really care about the crypto side, others do. And crypto has its use cases as well. So it's not a general purpose tool to be used.
The old parts, are they now mandatory then? Mandatory part of ARM chips?
Are the old parts mandatory part of ARM? No, Giselle has, to an extent, gone now. It is very much deprecated. There are certain use cases. We're working with the OpenJDK project to ensure that Java, there is a very good Java stack. So it's evolved, if you will.
One more question, if you don't mind, by the way.
Please.
How long do you expect the 32-bit components to stay around in 64 chips? And how easy is it to take it out if you want to? I mean, I don't know why you would.
So how long will the 32-bit components, so AArch32, remain within the ARM v8 architecture? I think it'll be around for quite some time. I really couldn't say for certain, but there's use cases. There's partners that want it, and as with most companies, customers are always right. So, you know, we're here to make money, so if somebody wants to pay us to do something, if it's reasonable, we'll do it. I mean, we expect ARM v7 to remain for quite some time. I mean, we're still selling ARM v5 licenses. So, and that's pretty old. I mean, the CPUs that were used in Nokia 3110s in the early 90s, still sell licenses for them. You know, it's a minimum of a 10-year cycle.
Is that a benefit from bumping it? Just having 64-bit only?
Is there a benefit? Well, some partners are only going to be deploying 64-bit only. There will be no 32-bit support in their CPUs that they sell.
You don't have chips. You don't have CPU models yet that have 64-bit only, right? Do you?
Do we have any models available now?
I mean, that's
64-bit only. I mean, we have.
53 and 57.
Yeah, well, the 53 and 57, you can choose what workload you want. Some of our partners, so the A53 and A57 is an ARM design. Some of our partners have taken licenses that enable them to fine-tune the microarchitecture. So, you know, in the existing...
their own, like Apple.
Well, exactly. I mean, Apple take a license from us, and the license that they've taken enables them to do modifications to microarchitecture.
Only modifications. You're saying that chip is based on the standard ARM 53 or 57 design, or is that done from scratch?
There are elements that are used. So with the ARM architecture, so the A53 and A57 applies to the microarchitecture of our design. The Apple A7 is a replacement for the A53 and A57. So it's not necessarily based on the A53 design or 57 design, but there are elements and base layers that work. So you know, some of the tool chain requirements and components. I mean, Apple have recently pushed their LLVM backend upstream. So it's not a simple that the ARM licensing is not a simple thing to wrap your head around. You really do need to spend a lot of time in understanding the little nuances between how partners are enabled. So yeah. So with ARM v8, we're taking our heritage and it's designed for efficiency. So the A53 and A57 designs are fully compatible with existing ARM v7 code. So you could just take your file system, 32-bit file system, drop it on and off you go. We are targeting emerging software trends with the V8 architecture. The ARC64 is a completely clean instruction set. It was built from the ground up. We didn't take 32-bit and try and extend it. It was designed from the start as 64-bit, so it's as clean as code can be. It's very modern. We've tried to look at how to improve aspects and design to maximize existing hardware and processors.
Can I have one more question? Sorry. Ideal for concurrent programming. I mean, what is it in ARC32 that makes it any different than the current CPUs? Or
so ARC32 is an evolution of V7. It's kind of V7.1, if you will. So it's taken how it's used and refined it slightly. So it's you can do concurrent tasks now that you weren't necessarily able to do previously under the existing architecture. So I've touched on Linaro as a key partner, and they are very much so. It's made up of our ecosystem partners, not just silicon vendors, as you can see primarily within the club area. If you look in the group area, you've got software vendors, Canonical and Red Hat. You also have people like Enea. You've got OEMs, HP, NSN. There's in the networking space, you've got Cisco as well, and you've got web services, Facebook, etc. And then we've got community members like IBM who provide, one of their reasons, they've been around for a long time. They helped set Linaro up, and they regularly provide some advice and guidance and assistance. So Linaro, with all those members, has created several groups, and for the data center, there's two key components, two groups there. There's the networking group, known as LNG. So it's focused on optimizing the network workloads for ARM. Software-defined networking is now the big thing for the enterprise. They're looking at ways of optimizing SDN. And it's comprised of a wide variety of partners there to ensure the maximum gain for everyone. The other group that's important is the enterprise group. It was the first subgroup set up within Linaro, and it's called LEG, to go along with your arm and our thumb. So it's, like I say, focused on the server workload, storage, I/O aspects of how enterprises want to deploy servers within data centers, and looking at how we can make sure that partners' platforms work on those specific workloads. So there's lots of new hardware coming out. HP have announced hardware, so is Dell, Mitek. There's lots of others that have announced what they're going to be doing. AMD and Applied Micro with their Seattle Optron processors, as well as Applied Micro's X-Gene family. So partners are participating to make the most of how things go. As I mentioned earlier, one size doesn't necessarily fit all. You don't necessarily need a big box to do a small load. So with the enterprise, you've got servers, you've got network devices. In the networking space, a lot of companies now moving from having dedicated embedded platforms to leveraging software and commodity hardware to provide the same sort of functionality, but at a lower cost. So with our partners, depending on which area of focus they're in, we can marry up their needs. So looking at optimizing the workload solutions will significantly generate better TCO. Total cost of ownership now is quite crucial. It always has been to an extent, but there are now more constraints on your TCO. Before it was just a matter of how much does it cost over 3 years for the hardware. Now it's how much does it cost over 3 years and how much power and cooling am I going to be using over those 3 years directly affect the TCO. And as the internet is always evolving, there's new features being implemented, there's new use cases coming out, the workloads are changing. So we're trying to be as agile as possible to be able to adapt to those workloads. And ultimately, people are looking for as much value as possible from their investment. There's a few partners that have managed to get units out now, and there's going to be more and more over time. It's not going to be a stagnant, slow drip. It'll soon ramp up. And part of the advantage of ARM's business model with its licensing, etc., is that it enables much higher rate of innovation and differentiation. And it's much easier for people to take a base platform and then provide value add on top. So as an example to that, you've got partners that are very strong in DSP technology. So they need something to bring up the DSPs, and then for video streaming, encoding, etc., instead of doing that workload on the CPU, where it would be much slower, it's all done within DSPs. So there are ARM servers out there now. There are ARM servers deployed in data centers at big companies. Currently based on ARM v7, ARM v8 systems are slowly starting to ramp up now. There are some partners that have pushed development boards out to key partners, as I mentioned, AMD and Applied Micro. So all those that you can see there are starting to ramp up now. They're all involved in the enterprise already. We've got OEMs that are now partnering to create those systems for customers to buy. And we've got software vendors who have platforms and products ready to run on those systems. So we've got a few people in the marketplace now. There are going to be more, and it will grow over time. HP was one of the early OEMs advertising their Project Moonshot with initially 32-bit servers in them, but they are also releasing 64-bit systems very soon. They've done a lot of exploratory work with the 32-bit platforms, so they're starting to understand better how their end customers want to use their systems. They're able to then work with the silicon vendors to ensure that they can provide maximum value. AMD's got a lot of experience in the server space. They announced their Seattle 64-bit processor, up to 128 gig of RAM per server. It's much more dense. It can take up less space, less power, but provide the same productivity that customers need. So it's all about integration, ensuring that each component works well, and that ultimately reduces TCO. So an existing server, you've got a single CPU socket, a few DIMM slots, and a couple of SATA connections for storage. What our partners are doing is condensing that large footprint into a small card, much like a GPU card that you put in a desktop or something like that. It's comparative in size, really. And those cards have quad-core, octa-core CPUs. They've got DIMM slots. They've got storage slots for that server, or fiber connections for a SAN. So we've taken that large footprint of a server, squeezed it down into a card. And then to get multiple servers, they go onto a baseboard that's in the chassis. So a 4U server unit that you may have a 16-core server in with 64 gig of RAM and 6 disks. Now you've got 100 quad-core servers, each with 8, 16, up to 128 gig of memory, each with a single disk if you wish, potentially 2 disks. So you're managing to lower your footprint within the data center, so you don't need as much rent to pay for your data center. You don't necessarily need as much power and cooling because the power draw from those servers is lower. It gives you that flexibility. You can have one of these servers, a single 4U box, in a satellite office, quite easily in a small comms room. You don't necessarily need to have a small data center for one of your regional offices. The Open Compute project has taken a slightly different approach. They don't actually have any server chassis. They have effectively shelves of servers, and they've got a fail-in-place policy. So they have one cabinet, 42U rack with literally nothing but CPU modules, and associate cooling with that. Their storage goes in a similar fashion. But if a server fails, one of those smaller cards fails, they don't care. The workload gets moved to another one of those cards. Until there's a percentage of units that have failed, then they just take one shelf out, slot a new shelf in. It's much quicker, much easier for them. And they're able to then design how those units are created, they can fine-tune workloads to ensure that they get the most out of it. So, as I said, ARM servers are in the enterprise already. Baidu is one of the largest users at present. Their cold storage, for those that don't know Baidu, they're very similar to a Chinese Google type cloud service. They've got a social network, they've got search, they've got you name it. So for them, ARM servers fit their cold storage requirements perfectly. Mitek have announced their Applied Micro powered 64-bit server. That's starting to roll out very soon. And as I said, HP's Moonshot is also ramping up. HP is not the only big name OEM that's releasing though. Dell, with their Project Copper, has done a lot of proof of concept work to ensure that they can get the best out of it. They're not hedging all the bets on a specific architecture. They work closely with their customers and their partners, and it's starting to get bigger. There's more traction going. So, in summary, the workload in data center is shifting, moving towards more optimized, dedicated platforms, almost the old Unix way of do one thing and do one thing good, rather than being general purpose. Our partners who are producing the CPUs that are going into these units, they understand how to integrate SoCs. Many of them have been doing it for a long time. A lot of them have been in the mobile space, and they're moving out and growing. And we've released the first of many standard or standardization efforts to ensure that our partners can get the most out of it. SBSA is a key foundational specification, but it's just because we've released that and our partners appreciate it and enjoy it, we're not going to sit back. We are working on ensuring that there are more specifications and ensure that standardization is a key component. So, any questions?
A few, if you don't mind.
I do mind.
Oh, well, I can stop. No, I find this interesting. One question I had was, I mean, the per CPU throughput of these is lower than what, let's say, the big elephant in the room, Intel, is delivering to the customers right at the moment. Now, there has been a company that had tried this many small cores thing before, which is the Illuster Sun. Their Niagara, I remember, was one of their first attempts at that, and there have been other chips. Perhaps Oracle is even still shipping some of that stuff. And I recall it not working very well. What are your thoughts on that? Why did they fail, and why will you succeed, you being ARM here?
I think part of the issue was the software stack.
Really?
We are working upstream, standardized. We're ensuring that we work with the wider ecosystem, not just our small focused one. Because we have no definitive expectations. I mean, we don't expect now that there's ARM servers moving in, we're going to take 40% away from the entrenched incumbents. It might happen. It'd be great if it did. But we have no way of guaranteeing that. So working with the open source community, with the Linux community, you look at data center now, most workloads are running on Linux. It's very much split between Windows and Linux. The Unix space has shriveled up. So we want to make sure that customers have the widest choice possible. So working with as many Linux vendors as is feasible, working then with those vendors' partners to ensure that we have as broad a portfolio available for people to use. And it's up to, and because we don't build anything, we let our partners come up with the innovative ideas. They know their customer base best. If they think that, they've got customers that are using these big units for VDI solutions, as an example, they can tune their servers to be well suited to VDI. They can pick specific segments that they want to dominate. It's not for us to say how to do that. We provide the foundation and let them then build the house on top of that, and we work with the ecosystem to furnish that house.
I think it's quite a vote of confidence that AMD decided not to use one of their own Jaguar-ish cores, but instead go for ARM cores. But Intel does go for Atoms, of course. How do you see the Atom server systems that are, well, I'm not sure if they're already on the market, but coming? How do you see those stack up compared to what you guys are doing?
I've not seen any benchmarks, if you will, of how things go, but there's a use case. There will be a use case for ARM that won't fit Atom for whatever reason, be it power consumption, be it throughput, whatever. And vice versa, there will be a use case where Atom actually fits better than ARM. At the minute, customers don't have a choice. You go to a single CPU vendor and that's what you get. Sure, you're going to get some units with AMD Opterons in them, but it's nowhere like it used to be.
You think customers are desperate for choice at the moment in the server market? I mean, I can't judge at all.
Certainly, I would say OEMs would like choice. They would like to choose what CPU goes in. And I think they're feeling some pressure from their customers saying, I bought this box and yeah, it's great, but it's so underutilized. No matter how I play with that, whether it be with virtualization or whatever else, I'm just not using it to the best of its ability.
You think ARM can get a higher utilization percentage? At least the architecture, the technologies you're building, higher than what current servers can do?
I certainly think there's a possibility. I mean, anything's possible at the end of the day.
Well, sure.
So,
but what's
with us
blocking
coming
the current
with
technologies then?
Sorry?
What is blocking the current technologies?
Within the enterprise space, 64-bit is the standard.
Yeah. But I don't mean the current ARM, but what is blocking enterprises to fully utilize Intel boxes?
How they deploy workloads. And changing how they deploy those workloads is potentially too disruptive. They'll need to rethink of deployment methods and configurations. It can be quite
hardware and software, basically. It's a combination.
Exactly. There's a lot of things that interconnect, and just changing one won't necessarily bring any advantages. So being able to provide solutions that are built for those workloads is a big advantage. Oh, sorry, it's just up there.
On the software side, are we done? What are the big obstacles at the moment? Because this V8 hardware is just coming slowly. But are there big things to be done on the software side, or are we just waiting for hardware? And maybe the second part, Linaro has been announced in 2010 or something like that, launched. And how long will they be needed, or how long will they be around? Is that an effort that will continue forever, or will they next year say, okay, we are done, it works, and the consortium will dissolve itself?
So to answer your first question of, are we done with the software? No. There's lots to do. Things may be functional, but in comparison to competing architectures, they don't really perform too well. So there's going to be a lot of optimization work required. Some of it works great, but some needs a little bit of massaging and a little trimming of the fat, if you will. As for what big chunks are missing, the Java stack is almost there. The OpenJDK port was done from the ground up, so it's, again, much like the ARM v8 architecture, is very clean, but it's taking a bit of time because it started from scratch. And as with most software things, if you don't have hardware to test it on, it gets quite difficult. Using models, emulation, etc., is good for functionality testing. You can't really do any performance testing and such like unless it's on real hardware. So there's, as much as there are certain workloads, like I say, that work great. Some software stacks don't really need much tweaking, but being engineers, we'll forever tweak things. We'll find new ways of doing X, Y, and Z. So there is still quite a bit to go. As for the second part, with regards to the Linaro, will it be disbanded in a year's time, etc., or in a few years? I really don't know. At the moment, it's working well, and they are helping in the ecosystem to do a lot of that optimization work, the fine-tuning. So it could be around for a long, long, long time. Who knows? It depends. And if partners feel that, yeah, it's all done now, we don't need to do any more, that will be the deciding factor. But at the minute, I think there's still life in the old dog.
Okay. Thank you.
So you said that what is currently holding back customers to utilize their Intel hardware is the way they deploy their solutions on top of it, and that ARM will be the solution to that. If customers are nowadays hesitant to change the way they deploy their solutions today, why would they want to change and deploy ARM systems, which are not only changing the way they deploy their workloads, but also the way they deploy their servers, their hardware, even build up their data centers? Why would they want to do that if they are not willing to change a simple way of deploying their software?
It's not just a matter of how they deploy. There's lots of factors that you have to take into account for utilization. How do you get the most out of your hardware? One of the reasons why VDI started to spring up was because you've got all these desktops that are sucking out power, etc. Nobody really needs them all the time, so you deploy VDI. You can power up, power down desktops. You can expand, contract your sites almost at will. So it's not just that, but you are right. There will be an element to take into account if they're going to move to a different architecture for their software stack, etc., that they may need to change. But hopefully our partners can provide systems and solutions that are built in such a way that to get that workload on an ARM server is much easier than having to fine-tune your workload on an existing architecture to be able to maximize utilization.
Okay.
Any more questions? Thanks very much.